For this review video, we're going to work on just taking derivatives of some random functions. I've pulled up some practice problems and I'm just going to go through them piece by piece. So for the first one, we're going to have y equals 4x to the fourth plus 4x squared. Nothing special with this one. To find the derivative, I could write it as y prime. I could write it as f prime of x, but I don't recommend it if they didn't use f of x. I usually give myself a dy dx. Power rule, 16x to the third plus power rule, 8x. For the second one, I'm going to give our brains a little bit of a twist here and say, now I realize that you could do the problems I'm getting ready to do by distributing first, but I want to practice the product rule. So let's go with y equals 2x squared times 2x to the fifth plus 1. And part of the reason I want to practice the product rule is because later on we might have a chain rule involved and multiplying it out would not be as efficient. So we're going to say f is 2x squared, our first expression. F prime is 4x. G is 2x to the fifth plus 1. G prime is 10x to the fourth. For the product rule, we're going to do f prime g, so dy dx equals 4x times 2x to the fifth plus 1 plus g prime f, 10x to the fourth times 2x squared. And we are going to simplify because it's good practice. We have 8x to the sixth plus 4x plus 20x to the sixth. So altogether, 28x to the sixth plus 4x. I could pull a GCF out of that, and if I needed to try to simplify, I would, but there's really no reason when we're just working on derivative rules. Final answer equals y prime. All right, let's try another one. Let's go Let's go with the quotient rule this time. So they gave us some pretty simple ones. Let's see what I can do with it. Y equals, let's do x squared plus 3x over x to the fourth plus 5. The top is always your f, x squared plus 3x. F prime is going to be 2x plus 3. The bottom is g, x to the fourth plus 5, and g prime is 4x to the third. So, for the quotient rule, dy dx equals f prime g, 2x plus 3 times x to the fourth plus 5, minus g prime f, 4x to the third, x squared plus 3x, all over the bottom, x to the fourth plus 5 squared. It's very seldom that you actually need to multiply out the bottom, the x fourth plus 5 times x to the fourth plus 5. If you think there's a way you can simplify, that's fine. You do have to FOIL or box here because you have two binomials. So dy dx equals 2x to the fifth plus 3x to the fourth plus 10x plus 15. I'm going to distribute my minus 4x to the third, so minus 4x to the fifth minus 12x to the fourth, all over x to the fourth plus 5 squared. Combine like terms, good practice. Dy dx is negative 2x to the fifth minus 9x to the fourth plus 10x plus 15, all over x to the fourth plus 5 parentheses squared. Now, in this answer, this is the way I write mine because I prefer for my powers to be descending. However, a lot of people don't like having a negative lead term, so they will turn it around and do 15 plus 10x minus 9x to the fourth minus 2x to the fifth, but it's the same answer. All right, so that was quotient rule. Let's see what I have next. A little bit of chain rule. What problem? This is number 4. Chain rule. So if we have y equals, pretty simple, parentheses, 3x to the fourth minus 5 to the fourth. dy dx, The power is my outside, so I'm going to do that first. 4, subtract 1 is 3, and I keep the inside the same. Then I multiply by the derivative of the inside, which in this case is just 12x to the third. So dy dx is 48x to the third times 3x to the fourth minus 5 to the third. A little bit of trig for us, some basic. Oh, these have a little bit of chain rule with them too. So I want to look at a couple of different ways that this could happen. Let's say we have, I'm going to do the same problem 3 different ways. Well, I'm going to do the same idea with the problem written 3 different ways because they all mean something different. So let's do y equals sine 5x squared. In this case, the 5x squared is the angle. The square is only on the x. That's very important. So sine is the outside function. The derivative of sine is cosine. Keep the 5x squared. Then derivative of that is 10x. So dy dx equals 10x cosine 5x. Whoops, the square's in there. Okay? Now, I want to rewrite that problem. This time I want to have it as y equals sine 5x squared. Now, very simply, I could square the 5x and get 25x squared and do the same thing. However, just in case you don't think of that, sine is my primary function, my outside function. So I'm still doing cosine of 5x squared. The derivative of my angle is chain rule itself. So I'd bring my 2 around, 5x to the 1. Then I do the derivative of 5x. So altogether, 2 times 5 is 50x cosine 5x squared. Notation is very important, guys. Don't forget about it. One more time, same problem, but this time we're going to have y equals sine squared 5x. This time the square is on the sine, so the square is my outside function. So I bring the 2 around, I keep the sine, subtract my power of 5x. Then I do the derivative of sine, which is cosine 5x. Then I do the derivative of 5x, which is 5. So this one would be dy dx. 2 times 5 is 10, sine 5x, cosine 5x. So that gave you a little bit more to think about. And hopefully this is just a very brief overview of the basic differentiation rules from Calc 1. Hopefully that helped. We're going to do the same thing with integrals in the next video.